Hi thinkers, welcome to the Algorithms in Python playlist on ThinkX Academy. In this tutorial, we are going to cover the binary search algorithm and we are going to use recursion to solve this algorithm, which is basically to search an element inside a given array. In this playlist, we have already implemented binary search using the iterative approach, and now we are going to use the recursive approach. So I will first explain the whole algorithm here, and then we will write the same algorithm in Python, and then we will see how it actually works. So the first thing we are going to do is we are going to understand what is binary search. And here you can see we are given an array which has these 6 elements, which is 5, 10, 12, 30, 41, 50. And we are given an element x here, which you can see the value of x is 41. So what we just need to do is we want to find out where this element lies in this array, and we will use a binary search approach. So first thing is we need to calculate the left position, which is here, the right position, which is here. So we first calculate these two positions, which is left and right, and then we calculate the middle position. So middle position is actually calculated as L plus r minus 1 divided by 2. So we will then calculate the middle element, and you can see here left has a position 0, and similarly we have these positions here, and the right position is 50 here. So 5, so 5 minus 1 divided by 2, and from here you can see the answer that we have here is 2, right? So we calculate the mid element like this. So we will get this element as the middle element, and then what we do is the algorithm will compare this element with the element that we want to search. If this element is equal to the element that we wish to search for, then we are going to simply return the index of the mid, and if we find out that it is less than, you can see we are now going to compare the value of x with the value of mid. So we will do that when these are not equal. So you can see that this array is sorted, and we know that binary search works only on the sorted array. So here I am going to write here that the array has to be sorted. Now you can see that x is 41. So first now what we will do is we compare it with the mid value, and after comparing it with the mid value, you can see 41 is larger than the mid. It means that it is going to lie in this part of the array. If this value of x becomes less than the mid, then we are going to look for this part of the array. Now you can see that we will have to apply the same algorithm for this array also. Right now just consider this subarray and ignore this part, because now you can see that the x will lie here. We have got that from our algorithm. So now you can see that we will have to again calculate the mid. The left position was initially 0. Now we will have to reassign it to the middle position, and the right position remains the same. In case when we are considering this part, the left position remains same and the right position becomes the middle position, right? So now we know that it is going to lie here. We will calculate the mid position again, and you can see that 30 is going to become the middle element. We will again compare it with the x value, and then we will find out if they are equal or not. If they are equal, I will just simply return because we have found the element. If not, we are again going to consider the rest part of the array, and we are going to do it again and again until and unless we found out the right element, right? So this is a binary search approach. Now the question arises here when that how to find out whether we can use recursion to do such type of problem or not, right? So basically recursion is calling a function itself. So let's say I create a function, and let's say this function is a, and this function a is going to call itself, then this is known as recursion. So what is the actual need of recursion, and when will you know that you will have to apply recursion? So if you are given a whole problem space, you can see here that this whole array is the problem space, and you are going to apply an algorithm here in this case is actually to calculate the mid position and compare it with the value of x. Whenever you find out that the same algorithm is being applied again and again, but to a smaller part of the array, which you can see here. So if we have a whole problem space like this, right? So let's say this is the problem space. And now we want to apply an algorithm to this problem space, but also to the subspaces also. So let's say we have some sub problems also in this problem space. So whenever we want to apply the same algorithm over and over again on subspaces, we are going to use recursion, right? So let's see how we can use recursion in case of binary search. So the first thing we need to do is define a function. So first of all, I'm going to write the pseudo code here, right? I'll write the pseudo code here so that we can use the pseudo code to write and implement the same in Python. So the first thing is I will have to make a call to the function, which is the binary search function. And to this function, we will first have to supply it with the value, the whole array, which is here. Then we need to supply it the value of left position, the right position, and the element x. So this is the function call. We can see initially the value of L is equal to 0 and the value of R is equals to n minus 1, where n is the number of elements inside this array, right? So you can see there are 6 elements inside the array, so the value of R will be equal to 5. So we supply the value of L equals to 0 and R equals to 5 in the first case. Now what we will have to do is we will have to calculate the value of mid. Now before calculating the value of mid, I'm going to write a condition here. If the value of L is less than equal to R. So we are going to get an entry point here, which is this test case here, which says that if the position L is less than or equal to R, then only we are going to perform the next steps, which comes under this function. So we will understand this case, what is the importance of this case. I am marking it as star here. We will discuss it after we will cover the rest of the part of the algorithm. So now what we want to do is the first step is to calculate the middle position. And we know to calculate the middle position, we will just write this simple formula, which is L plus R minus divided by 2. So now I have calculated the value of mid. Now what I am just going to do is I am going to just say that if the value of x, which is the element we want to search for, is equal to the element at the middle position, then we are going to simply return the middle position. Right, so we will just simply return the middle position because at this position we have found out the element. So whenever the value of x is equal to this, we are going to return the value of mid, right? Now what will happen if the value of x is less than the value at the middle position? Now you can see that if the value of x is less than the array mid position, then it means that it is actually going to lie in this part of the array, right? For that you can see that the whole problem can be now divided into this sub problem. This is actually going to become a sub problem. So this sub problem will also be have the same algorithm. We will have to apply the same algorithm. But you can see the value of left and right will have to change here, right? So whenever we want to apply the same algorithm but on a different subspace, then we are going to use recursion here. So since we want to apply these steps, which is calculate the mid and return the mid if x is equals to the element at the mid position, we are going to call the same function, which is the binary search function. Right, so I am going to make a call to the binary search function, and you can see this will again call the same function again. So this is actually known as recursion. But you can see that binary search function will require these 4 parameters. So we will give these 4 parameters to this function. The first is the array itself. The whole array will remain the same, but now the left and the right position will change, right? So you can see that here the left position will remain unchanged, right? So it will be L only. When x is less than array mid, it means we are considering this part. So you can see that the left position is the same, but the right position is going to be mid minus 1, right? So you can see that mid minus 1, which is this parameter, which is the third parameter, is actually r, which is the right position, and now I have changed it to mid minus 1. The reason I have changed it to mid minus 1 is that we have already evaluated that this is not the value, so obviously this is going to be the array where we want to search the element x. So here that's the main reason I have assigned mid minus 1, which means one element before the mid, right? Now the element x will also remain the same. Now what this line here, what this will do is, it will call the same function again, but with different value of L and R. The value of L will be 0, the value of R will be 1, and this will now calculate the middle position using the values of L and R, which have now changed to L and mid minus 1. And now what will happen is, it will return the middle position if it gets it. If not, it is again going to make a recursive call again and again. But the question arises here that how will you stop this recursion, right? So if this function is calling this function again, and you can see that this function is going to call the same function again and again, it may become an infinite recursion, right? So we will have to avoid the infinite recursion. We will have to write a condition that actually stops entering the function, right? That actually stops recursion. So if we have the infinite case, we have to write a condition to stop the recursion. And this is the condition that I have written here. If the value of L, which is the left position, if it is less than equal to R, you can see that it will always have to be less than or equal to R. If the value of L is less than equal to R, then only you are going to perform these steps and also the recursion call, right? So you will make a recursive call only when this condition given here is satisfied. If it is not satisfied, then it means we are not going to follow recursion, right? So no more recursive calls will be made, because the function which has done the recursion will not be able to enter this part of the program. Now what will happen if, right, so I'm going to write here else if, what will happen if the value of x is greater than the mid position? In this case, you can see that we again have to call the same function, but with using different parameters. So now you have a good idea of when to use recursion, when you want to follow the same steps again and again, and you want to actually, right, so if you want the same steps again and again, but using a different parameters, you can use recursion, right? And remember to always write a condition that will have to stop the recursion, right? So we are making this recursion, and this recursion is guided by this condition here. So if there is no condition, it will go into infinite recursion and the program will crash. So what will happen when x is greater than the array mid position? We are simply going to make again a call to the recursive function, which is binary search. The array will remain the same, and now you can see we will have to change the value of left and right also. So when we are considering this part of the array, which is this part, you can see the R will remain same. So I am going to write R here. X will remain same, but the left position will change, right? You can see that we will have to change the left position here, because initially it was pointing to 0, and now we will have to assign it to one element after the mid position. So here what I am going to do is I am going to write mid plus 1. So now what it will do is it will call the function binary search again, and it will have the left position as mid plus 1. So L equals to mid plus 1, R is same and X is same. And then what it will do is it will compare the value of left and right. If it is less than equal to, then it is going to again calculate the middle position and return the middle position using this algorithm. So this is actually the recursive approach. And what will happen if we have done all the recursive steps but still we are not able to find the answer? So whenever the value of L will be greater than equal to R, we know that recursion has ended, which means the value of L has increased the value of R. It means the recursion is over. So what we will do is, if the recursion gets over and we do not get any value here, we are just going to return -1 here, right? So when we return -1, we say that we are not actually able to find the element inside of this given array here. So now we will write the same algorithm in Python also. Alright, so you can see here I have created an array with the same elements, which is 5, 10, 12, 30, 41, 50, and the element x is equals to 41. And now here you can see I have created a variable answer, which will basically hold the value which is returned by this binary search function. And we know that it will return the value only if it is equal to the mid position. So here I have made a call to the binary search function. I've provided it the array. The left position is initially 0 and the right position is actually length of array -1, and I have given it the value of x here. Now here in the implementation part, you can see I have defined this function with all of these parameters, and here you can see we have written a stopping condition here which actually stops the recursion. So I'm just going to write here that this is the stopping condition, and here you can see I've created a mid value, and this variable is actually L plus R minus 1 divided by 2. And now you can see here, you can observe here I've returned double slashes here because this actually gives us always an absolute value. So it will give us absolute value after division, because the integers are the only things that are going to show the index of the array. And now here you can see I've written x equals to array mid position. We are going to return the mid. If the x is less than array mid position, we are going to return this, make this recursive call here. So here I will just write that we are actually trying to do a recursive call, and this recursive call we are actually not changing the left position, it will remain same. The right position will actually be mid -1. So now this will make a call to the binary search function again, and here it will check whether L is less than equal to R, then only it is going to make further recursive calls based on these conditions that I specified here. And similarly we have this condition x is greater than array mid position, and here we have mid plus 1. So now you can see here if the answer is not equal to 1, so you can see this else case is when the L has become greater than or greater than R, then it means that we have not found the element and it is returning -1. So if this answer is not equal to -1, it means that we have found the answer and we have found the element at the position which is answer here. So now here you can see if it is not found, I will just write here that not found here, right? So now I'm going to save this program. And here you can see in the terminal, you can see the output here that found element at 4th position. So you can see that 41 is indeed at the 4th position. And if I change it to let's say 1, you can see that it must show that the element is not found, right? Because it is not present inside of the given array. So that's all for this tutorial. If you have liked this tutorial, make sure to like and share it with your friends, and also subscribe our channel for more future upcoming videos. So thanks for watching.